Okay, so 10.3 part 1. We're continuing to solve systems of equations, but here we're going to have 3 systems with 3 variables. So the first part of this says determine if the ordered triple is a solution, show all your work. So the ordered triple that we're given, this is going to be our x, y, and z. We have to plug each number into x, y, and z into each equation and see if it makes sense. So starting with the first equation, I'm going to plug in x, y, and z. So we have 3 times 3 minus 5 minus 3 is equal to 1. So 9, we can say minus 8 is equal to 1. Is 9 minus 8 1? Oh no. So is it true in the first equation? Yes. So it works in the first one. Let's plug it into our second equation now. So we have 2 times x, so 2 times 3 minus 3 times z, which is negative 3, is equal to negative 14. So 6 plus 9 is equal to negative 14. 6 plus 9 is 15. Is 15 negative 14? So does it work in the second equation? No. So then our answer here would be not an ordered triple. So it has to work in all 3. So you have to try all 3 of them, but if it doesn't work in the first one, then it's not an ordered triple. You don't have to try the rest of them. Just make sure your math isn't off. So as soon as it doesn't work in one, you're done. It's not an ordered triple, but if it's going to work, you have to check all 3 of them. Because like we did for this one, it works in the first one, but it doesn't work in the second, so it's not an ordered triple. All right, on the next page, we have to solve the systems of equations and write your answer as an ordered triple. So here, our system of equations, we have one equation with 3 variables, one with 2, and the other one with 1. So we use back substitution to solve. So we take our equation that has 1 variable, it's already solved for z, and we can take that and plug it into the one with 2 variables. So I'm going to plug it into y plus 2z is equal to 9. So y plus 2, what's z? 9 is equal to 9. So y plus 18 is equal to 9. We subtract 18 on both sides. So y is equal to negative 9. What do you think I do once I find y? Awesome. We're going to plug both of them into the first equation. So we have x minus negative 9 plus 5 times 9 is equal to 41. So x turns into a plus 9 plus 5 times 9 would be 45 is equal to 41. X plus 54 is equal to 41. We subtract 54 on both sides. So x is equal to negative 13. How do you think we would write our answer here? Negative 13, comma negative 9, comma 9. Awesome. X, Y, then Z. So just like how on the quiz yesterday, we had to solve for x and y, and we put it as an ordered pair. Here we just put it as an ordered triple. So we have x, y, and z. All right, so 10.3 part 2 is the same. We have 3 systems of equations here. So 3 equations, 3 variables, and we have to solve. So these are not going to be as easy as just back substitution to plug them in. But what we would do to solve when we have 3 equations with 3 variables, first thing I would do is label your equations. We have 1, 2, and 3. Next thing we want to do is pick a variable to eliminate. Looking at our x's, our y's, and our z's, which one do you think would be the easiest to eliminate? The y. The y would be perfect because they all have a coefficient of 1, so they all have the same coefficient. One of them's already negative, so that'll make it easy to work with to cancel. Sometimes it's not going to be this easy, but just take a look at your variables and pick the easiest one you would think. You could pick x's if you wanted to. I would just always recommend picking the one that looks the easiest. So if our coefficient's 1 and all of them, that would be perfect. All right, so next we have to pick 2 equations to work with at a time to eliminate the y's. And we have to eliminate the y's both times we do this. So which 2 equations do you want to work with first to eliminate the y's? 1 and 2. Good choice. So we're going to eliminate we're going to combine 1 and 2 to eliminate the y's. So x plus y plus z is equal to -1. X minus y plus 5z is equal to 5. Are y's going to cancel out here? Yeah, so we don't even need to multiply it by anything. Y's cancel. What's x plus x? 2x. Z plus 5z? 6z, and that's equal to 4. Now here we have an equation with 2 variables, so we can't do anything else to solve from here. So we're going to go and repeat that same step. But next we have to pick 2 other equations. We can't pick 1 and 2 again. We got to include 3 this time. So which 2 equations do you want to work with now? We can do 1 and 3, but I would maybe recommend 2 and 3 just because the y's are already negative. We want to cancel out the y's again. So if we canceled out the y's the first time, you have to cancel out the y's again. So I'm going to say 2 and 3 would be a little bit easier. You can totally do 1 and 3. You just have to multiply one of your equations by a negative. So we have x minus y plus 5z is equal to 5, and 5x plus y plus z is equal to 19. So x plus 5x would be 6x. The y's cancel, which was our goal. If they wouldn't cancel off right away, you'd have to multiply one of your equations by something. And 5z plus z would be 6z, and 5 plus 19 is 24. So you have to do this step twice. You have to pick 2 equations, eliminate the same variable twice. Next, any questions so far? All right, next we want to take the 2 equations that we just found and combine those 2 together. So we have 2x plus 6z is equal to 4, and 6x plus 6z is equal to 24. Now here we have 2 equations with 2 variables just like we did on the quiz yesterday. What could we do to eliminate one of our variables? Multiply one of our equations by -1. So I'm just going to multiply the first one by -1, change all the signs. Now let's combine them. So we have -2x plus 6x would be 4x. The 6z's cancel. And then -4 plus 24 would be 20. What do you think we do next? Divide by 4. So what does x equal? 5. So we found one of our answers. What do you think I have to do to find another? Awesome. We're going to plug it into one of the 2 pink ones up here, the ones that are highlighted. It doesn't matter which one. You can plug it into either one. You'll get the same answer. So the numbers look a little bit smaller in the one on the left. I'm going to pick that one. So just make sure you plug it into the correct variable. So we have 2 times 5 plus 6z is equal to 4. 2 times 5 would be 10 plus 6z is equal to 4. Subtract 10. 6z is equal to -6. Divide by 6. So z is equal to what? -1. Now we have x and we have z. How would we find y? Plug it into one of the originals. The numbers look a little bit easier in 1, but it doesn't matter which equation you plug it into. You can plug it into any one. So x is 5 plus y plus z, which would be minus 1, is equal to negative 1. So we plugged them into the original. So now we're just solving for y. 5 minus 1 would be 4. Subtract 4. So y is equal to negative 5. So we found x, y, and z. How do you think we would write our answer? As an ordered triple, yeah. What would go first? 5, then negative 5. And then negative 1. Awesome. So these are a bit more work than before, but you just have to make sure you're organized with it. It's pretty much the same steps every time. Pick 2 equations, eliminate the same variable each time, take those 2 answers, combine them together, and then it's just back substitution from there. Just wanted to add, same rules kind of apply when we have 3 systems versus 2. If you end up at any point when solving with 0 equals 0, what would our answer be? Infinitely many solutions. What if we had 0 is equal to some number 10? No solution. So it could happen right off the bat where you combine 2 equations together, like your first try, and everything eliminates, you get 0 equals 0. Your answer would be infinitely many solutions, and you could stop. So those are 2 possibilities also when solving these.